Hey, hi. Today is 16th of November, and this is what the daily we have. We have to find the power of a k-size subarray, which basically says that we have a array of integers and a positive integer k, where the power is defined for two cases. Like power defined as the maximum element in all maximum element. This is the powerful element if all elements are consecutive and sorted in ascending order. That means like if we have x, y, z, and p, q, then the x plus 1 should be y plus 1 should be z, and z plus 1 should be p. Then this order is consecutively increasing, and the maximum among x, y, z is my answer. And if it doesn't, then I have to print -1, and I have to find all the powers of subarrays. So if the array size is n and the window size, I would like to call it as a window because we are picking 3 elements at a time. So these will be 3, these 3 will be next, and these 3. So and so their total number of windows would be n minus k plus. So let's see. As today's daily is like the easier version of a problem, as we have 500 constraints, so I'll just try to solve it for the brute force manner. Like let's write this test case. So if what we have to right now is 1 2 3 4 and 3 to 5. So and our case, so these these and these are the windows, which is 1 2 3 4 5, and n is 1 2 3 4 5 6 7. So which is like total number of windows is n minus k plus 1, which is 7 minus 4 plus 3 plus 1, which is 4 plus 1 is equal to 5 as the number of windows we have. Then if we like try to brute force this, we'll just iterate from this pointer, like let's say I to I plus k, and we'll check if this condition is satisfied or not. Like let's look at this subarray. So we have 1 plus 1 is 2, 2 plus 1 is 3, and yes, this is satisfied. So my answer of this subarray is 3. Then 2 3 4, obviously 2 plus 1 is 3, 3 plus 1 is 4, and they're all increasing consecutively, so the answer is 4. But of this subarray, 3 4 and 3, this is satisfying. 3 plus 1 is 4, but not here. 4 plus 1 is not 3, so we'll have a -1. And here 4 3 2, obviously this is like greater, so this won't be a condition, so -1 here, and same for this subarray, -1. So this is what we get, and this is what we are getting. Our approach is correct, so we can write a brute force one. Like let's write a brute force one. So this is what we are having. I'll iterate from I is equal to 0 to I plus k less than n, and I'll maintain a boolean as true. So what I'll do is, if j is equal to y, j is less than I plus k and j plus 1. If I would go -1, so that when I'm accessing like +1 from standing here, I should access this, because if I will stand here and try to access something, it will give me an out of bound. So a nums of j should be nums of j plus 1 should be equal to nums of j plus 1. That means the addition of 1 to current element. If this can continue, else can is equal to false, and then let me gather a answer vector. If I have can still true, then I'll push back max element from ith window to this, else I'll push back a minus. I think this should work. This is working. But if it won't work if like the constraint are 1 5 and something like that, to which we have to use a technique called sliding window, where we have to pick every key sized window and try to solve on that. So my intuition is if I have to look into every key sized window, then I'll probably gather some information out of it. So let's type this 1 2 3 and 4 3 2 5 again. 1 2 3 4 2 5 right. The easiest way that I got in like intuition that I got to solve this problem was to initially treat as like what I can extract from it. So what I extracted is, let's store an order array where every ith index tells me that whether num size holds that condition with num size plus 1 of it. And what is that condition? That is num size should be equal to num size plus 1, like 1 plus uh, plus 1 is equal to this. So let's see this. So this holds, this 2 holds, this 2 holds. Or I can do one thing, that I should store something that it doesn't hold. Yeah, this would be fairly easy, as I can, it does not hold. So this holds, this holds, this holds, but this does not hold, it does not hold, and I'll have n minus 1 sized. Now for every second last element of the window, that is for this window I'll pick this, for this window I'll pick this window I'll pick this, and for this window I'll pick this. I'll check whether the sum of all like I would say yeah, order relations of all the cases window is 0 or not. Like how I'll do that? Let's say we have an array of 1 2 3 4 5 6, and someone asks what is the sum of all the subarrays of k sized. Let's say k is equal to 3. So this is 6, this is 9, this is 12, this is 15, right? So you can just extract it with sliding window. So this is where the sliding window comes from, or like really useful in this. So I can store a variable sum. I can first take the first window, which is 1 plus 2 plus 3, that gives me 6, right? So one window is 6, then add this and I'll subtract this, that is plus 1 would be added if I is there, and then I minus k would be I minus key plus 1, I guess, would be like basically that this element would be subtracted. So, or I'll just stop, like instead of calculating all these things, I'll just put a pointer j here. So I'll add I plus 1 and like subtract j and increment j here. So the next would be 6 plus 4 minus 1, which is 10 minus 1, 9, which is exactly our sum. The next would be this minus plus, which is 5, like 9 plus 5 minus, we have 9 here, right? So 9 plus 5 minus 2, which is 12, which is what we have there. Then 12 plus 6 minus 3, which is 50, which is what we have. So we will try to implement that on this order array, and if we get that sum of a subarray of a size is equal to 0, then we will just push that element there, like the maximum of that. Because if we know, and the question is where will the maximum come from, so imagine we have a, b, c and d, and these, they hold a relation here, b and b plus 1 is equal to c, and c plus 1, sorry, 1, c plus 1 is d. Then we all like this is increasing, right? A is less than b, less than c, less than d, and we'll always have the dth element as the maximum. So if we have element a, b, c and d who they have this like order array as of this condition, then we'll know that these are largest element. So this was the intuition and kind of implementation here, and I hope I was kind of clear and descriptive. So let's change the question. I'm trying to solve the second problem here, which has a like 1 5 and 1 6, or like where the brute force won't. So the same. I'll first extract the size, create a vector array of order, initially always zeros, and iterate to the n minus 1 and minus 2 basically. If nums of I plus 1 is not equal to nums of I1, I can write this as this will be 1. Then as I told you, like 1 2 3 4 5 3 2. So for this case as array, I'll just initiate the sum of order till this point, and then we'll start adding this, removing this, then adding this, removing this, adding this. So I need 2 pointers, like 1 to here. I'll put right here and put left, and I need a like sum, like which I'll be adding and subtracting. Let's put a counter as 0, and I said that I'll do it to the second last element of the window, which is k minus 1, k minus 2 actually. So like let's like this. I have that counter, and I need a left pointer, and right pointer would be at k minus 2. So while is less than n minus 1, so that if I'm standing here, I can access here, but I should not go there because then it will throw error. If counter is 0, That is if I'm like, let's look at this order of the current array, which is yeah. So this is 0, this is 0. So now my counter sum will be 0. That means this is the maximum element do I have, right? So this array is now increasing because we only need n minus 1 relation to decide for the n numbers. That means, sorry, I forgot to create an answer array. Dot push back was the nums of right plus 1. We keep on standing here at the second last element. So this will be my greatest element. Same happens here, same happens here. Else minus n if my right pointer is not equal to n minus 1, that is, if I'm not standing here, like I'm somewhere here, then what add the next and subtract the least I added, if I don't want, and then and given both it, I think that should work as, oh, I just crossed the line, it shouldn't. I should be putting n minus 2 so that I'm not on n minus 1. Yes. Yes, this works. I hope the explanation was clear, and yeah, have a good day.